Okay, class, today we're going to be covering chapter 13, which is titled Polynomials. And we're going to be focusing on the concept of factoring. Remember that in the previous class, or the previous chapter, chapter 12, we also looked at polynomials or binomials. Remember that poly means many, many nomials, many components of an equation. So in particular today we're going to be factoring out or simplifying or taking apart the long algebraic sentences that we have been working with. Okay, so I'm going to go ahead and begin with the class. Okay, so with factoring, one of the things that we need to look at is what is factoring? And factoring is pretty much expressing a polynomial as a product. Remember that a product is a multiplication, right? And within that product, you're going to find terms. By terms, I mean the coefficient and variables that each monomial or each component of that polynomial has in common with each other. Another thing to keep in mind that goes hand in hand with factoring is the concept or finding the greatest common factor. If you recall from previous classes, and for example, looking at the greatest common factor between 10 and 20, we're going to pretty much look at how many ways can you multiply. What are the numbers that you can multiply with each other or multiply by other numbers to obtain a 10, for example. In that case, if you multiply 10 times 1, it gives you 10. If you multiply these two numbers, the 5 and the 2, it will give you a 10. So thus, the 10, the 5, the 2, and the 1 is a factor. In the case of 20, we have very similar numbers. We have 10 times 2 gives you 20. 5 times 4 gives you 20. And that's just about it. And the 1, because 20 times 1 gives you 20, right? So what is the greatest common factor? The greatest common factor is what is the biggest number that both have in common. In this case, it would be the 10. So how do we apply that to the monomials and the trinomials and all of those funny nomials that we're going to be dealing with? So an example that I like to tell people is that for example, you are looking the least number of variables of the same type is what's going to be limiting what you're going to factor or extract from that particular grouping. So in the case, if we look at what is the greatest common factor between the 4x to the third and 2x, the way that I broke down 4 is 2 times 2. And then I continue breaking down the x to the third. It has 3 of them. In the case of 2x, we cannot simplify it any further. So in this case, the greatest common factor between 4x to the third and 2x would be 2x. Because you can only take away 2 from this side. You cannot take away 4 because there is no way you can divide a number into 2 and get 4. So any whole number, I mean, not a fraction or a decimal. Okay, so in this case, the greatest common factor would be 2x. Now, let's take it a little step further here now, and we have 3 monomials. So we'll have 7p to the third, q to the fourth. We have 21p to the first, q to the second, and we have 14p squared times q. So the common number that all of them have in common is a 7, right? Because 7 is a multiple or a factor of 21, and 7 is a factor of 14. Now, of p to the third, you're going to be looking, a trick to finding out what's the common multiple for a factor, or for a variable, I'm sorry, would be to look at the variable that's common in all the 3 terms or in all the terms in which you're trying to find the greatest common factor and look for the smallest number of it. So in this case, we have 1 here. This has 3. This has 2. So the greatest amount of common factors is 1, or p to the first, right? Keep in mind that whenever a variable doesn't have a number on the top as an exponent, it automatically becomes a 1. And in the case of the q's, we have q to the fourth, q to the second, and q to the first. So the one term that they all have in common is they all have a factor of 7, a factor of P and a factor of Q. Okay, we're going to go ahead and continue working with this so that I can show you with further examples. Okay, so here we have 3 examples that we're going to be working with so that I can show you what I mean as to the process of factoring. So the first example, I have example A, in which we have 3x squared and a plus 6. So it would be 3x squared plus 6. Here, we're trying to find the common denominator, the greatest common factor between the 3 and the 6, because there isn't a variable on the 6, right? The variable only exists in the first component of that of this monomial here. So the greatest common factor between the 3 and the 6 would be a 3, and the way that you would write that would be a 3 with a parentheses, and then you're dividing the factor that the number that you're factoring, or the variable that you're factoring from the original polynomial, you're going to be dividing. So if it's a coefficient, such as in the case of 3x, you're going to be dividing that 3 by 3 itself, so it will leave you with x to the second, right? And from the second term in that polynomial, you're going to be dividing that 6 by 3, which will give you a 2, and we carry that positive sign. Now, one thing to keep in mind is that if you want to verify to make sure you did it correctly, or that it is true as far as simplifying it goes, you can always redistribute this 3 into the problem that you came to, or you simplified, to verify that it's true. So let's just go ahead and do that by redistributing that 3. So 3 times x to the second will give you 3x squared, and then 3 times 2 will give you a positive 6, correct? And 3x to the second plus 6, it was our original problem, so therefore it's correct. Okay, let's look at the second problem that we have here. Here we have 20x to the third power minus 4x to the second. So here we have an example where we have both coefficients that could have a greatest common factor with each other, and we also have variables that would also have a greatest common factor within them. So the one thing that I want you guys to understand is that picture an example that if you go out to eat with friends to a place, and let's say it's 3 of you, one of you has $10, the other one has 5, and the other one has 20. The only way that all of you guys can go out to lunch or dinner or to eat is if you can only spend a maximum of $5, which is the only person that has the least amount. That's what's limiting where you can go. So in this case here, the greatest amount of x's that you can take would be 2, because that one has 3. So that would be our greatest common factor for this term here. And for the coefficients, we have to get the common factor. So in this case, what number goes both into 20? That also goes into 4. So it could be 2 or it could be 4. So the greatest one of the 2 would be 4, correct? So then we have 4, and we said that the variable is going to be x to the second power. So now divide the 20 by 4, and it's going to give you 5. Remember that whenever we multiply or divide variables with exponents, we subtract, correct? So we are dividing x to the third divided by x to the second, so it would just leave us with x to the first. Okay, and then we carry that negative, and dividing negative 4 divided by 4 will give us negative 1, and x to the second divided by x to the second will cancel out, so it will give us that as an answer, just the 1. It doesn't have any leftover variables. Again, to test out that we did it correctly, we redistribute the outside numbers that were factored into the original, into the answer that we got, to make sure that it matches the original problem. So we're going to multiply 4 times 5 gives us 20, and then x to the second times x to the first, gives you x to the third, and then negative 4 times negative 1 gives you negative 4, and then we just carry over that too. Okay, so there it is. The original problem is here. So the way that we did it was correctly, and this would be our answer right here. Okay, and for the first example, our answer is this. Okay, now let's look at another problem here. We have covered in the first one we did only variables only coefficients. In the case of this example, we're going to see what is there if there is a greater common factor between the coefficients. Is there a number that fits into 4, 2, and 3? And it doesn't, right? Because the factors of 3, it's 1 and 3. The factors of 2 is 2 and 1. The factors of 4 is 2 and 1 itself again. So they don't have anything in common. So we're only going to worry about the variables. And remember that we said that the limiting number or the limiting variable or amount of variables would be the smallest number of variables present in that polynomial. In this case, we have 4, we have 2, and we have 3. So our limiting or our greatest common factor would be the y to the second. And the way that you would work the problem would be 4y, and you took 2 from those 4, so you're left with 2. We bring down our positive, and we have the 2, right? So now we took 2 away from those y to the second here, so it doesn't leave you with any variables here. And for the last one, we have 3y. You're taking 2 away from those 3, so you're only left with 1y. And our answer would be just this here. Okay, so another way of factoring is a concept that is called factor by grouping. So in this case, we're going to treat the y to the third in front of x plus 4 and 5 plus 5 in front of the x plus 4 as a single, let's say, monomial, and we're going to see what the first component of this binomial has in common with the second component of binomial of the polynomial here. Okay, so what both of them have in common is the x plus 4. So what we can do is we'll factor out an x plus 4. Sorry here. We'll factor out an x plus 4 because that is what's in common, correct? And now we're left with, in the first component, y to the third plus 5. Okay, because the reason why we keep the plus 5 here is because these two groups are being joined, quote unquote, by a plus. So you have to carry that plus. If it was a minus, you would bring down your negative here. Okay, so you factor it out, and if you were to redistribute first the y to the third into this problem here, and then eventually that 5 into this problem here, and then eventually if you remultiplied everything here, you would get the same problem. So this is just a little trick of refactoring. This is going to be coming in very handy when we come to simplifying equations, and also when we look at quadratic equations as well, which will be covered in the next couple sections. Okay, so now the one thing that you guys got to keep in mind when you're factoring by grouping is that you want to group terms that have something in common. So for example here, what I mean by that is this. We can group together the x plus x as a single component, or we can group together these two terms, but they do have the x in common. Here the 4 and the 4 are the same thing, have a common factor of 4. However, if you were to group the 4 with the x to the second, there is not much you can factor out. So in this case, we're going to group them together as x to the second plus x. When you factor it out, it gives you x times x plus 1. And then the second set or the second group will be 4x plus 4, when you factor the terms here, it's the 4 that's in common, so you have 4 times x plus 1, because if you redistribute again the 4 into the polynomial, the binomial that you simplified, you get 4x plus 4, which is what the original problem was. So now these are two terms that are that we have to look at to see what they have in common. As you can see, both of them have the x plus 1. So your answer is going to be x plus 4, because this 4 came from the positive 4 here, right? So you have x plus 4 times x plus 1, the x plus 1 being that greatest common factor. And I'll back it up a little bit so you can see. Remember, right now you're only simplifying, and eventually to simplify, down the line you can go ahead and start canceling and reducing numbers so that it'll make it a lot easier to work with. Okay, and let's look at this third example here that we have. Again, we're going to be looking at ways to factor this this term here by grouping it. So what I would do, I would go ahead and group the x to the third plus x to the second as a single unit or a single group. And then the second one, I'm just going to group them together because there's nothing else to group it with. So we'll just keep it as x plus 1. So when we factor out from the first binomial here, or monomial, the one variable that they both have in common is an x, and the maximum amount or the greatest common factor in exponents, it's 2. So technically you can factor out an x to the second from that grouping. So that gives you x to the second here. Remember that we are taking 2 away from that 3, so it'll leave us with x to the 1. And here we have x to the second being divided by x to the second, so it gives us 1. Again, once we redistribute it back into the problem into the end result that we got to verify just in case to make sure that we have the correct answer, and it's x to the second times x gives you x to the third, and x to the second times 1 gives you x to the second. So now look, here we have this. Here we have the following greatest common, or the terms that are going to be related to this example here. You're going to have x to the second times x plus 1 plus x plus 1. Okay, so now again, what does this term have in common with the second term here? They both have x plus 1 in common. So your answer, to simplify it, is going to be x to the second plus 1. Mr. Ojeda, where did you get the plus 1? Remember that there is a 1 in front of the grouping, because technically it wouldn't affect the answer. So you put a 1 here, and the one term they both have in common. So your answer here would be x to the second plus 1 times x plus 1. And for the first problem, our answer is this here, x plus 4 times y to the third plus 5. And for our second problem, maybe I should have done this a little bit different, sorry guys. Our answer would be x plus 4 times x plus 1. There you go. Okay, and I'll back it up a little bit here. Okay, so for the following section, we're going to be focusing on factoring trinomials. Last week, or actually in the previous class in chapter 12, we looked at distributing or the multiplying or distribution of with using the FOIL method. So today we're going to be looking back. We're going to be working back from the result that you would get from the FOIL method. The way that you would work with these types of problems, they're called trinomials of the type ax squared plus bx plus c. So the simplest way to determining the sign of your binomial, such as in the case of here, would be to I have the instructions that I have created here. It says the first step is to look at the second sign. What do I mean by the second sign? So you're going to be looking at the second sign, such as in +6 and +6 here. It says that if it's a positive, then both parentheses will have the same exact sign as the first sign. So what does that mean? Okay, so in the case of the first example, we have x to the second plus 5x plus 6. So we're looking at the second sign, it's a positive, so both parentheses here will be the same sign as the first sign in the original trinomial. So both of them are x plus and x plus here. In the case of the second example here, we have x to the second minus 5x plus 6. So we look at the second sign, it's a positive, so that means that both parentheses are going to have a negative, such as in the case here. X minus and x minus. Let's not worry about the term on the right of the negative sign or on the right of the positive sign here. Okay. However, if it has a negative on the second sign, then one of the parentheses will be a positive and the other will be a negative. So let's look at an example of that. And we have x to the second plus 1x minus 6. So if we look at the second sign, it's a negative. So that means that one is plus and one is negative. In the case of the second example, it's x to the second minus 1x minus 6. Regardless if they're both the same, as long as the second sign is a negative, both of the terms in the parentheses will have a negative and a positive. Okay? Now, when it comes to looking at the multiples for the last digit within that monomial, we gotta see the ways. I like to call it, how can you make 6, for example, in this term. We already determined that if you split up x, it's going to be 1x in the front, 1x to the second, right? Because you only have 2. If it was x to the fourth, it would be x to the second and x to the second. Now, in determining what number goes after the plus here and after the plus on this side, we have to look at the ways to multiply that number 6. So the way to multiply 6 would be 6 times 1, or another option is to go with 3 times 2 equals 6. Okay, so we said, right, that we're going to look at the second sign, which we have a plus here. So that means that it's going to have, this parentheses is going to have, sorry, I had to turn off the light on that one. So this parentheses are going to be with a plus here and a plus on the second one. Just by looking at the second sign, again, we're looking at the second example here. So we have, it's a positive, and both parentheses are going to have the exact same sign as the first sign here. So we'll have a negative and a negative. Okay, so now on the first one, we said that it's given that it's x to the second, we're going to split it evenly. So there's an x and then x. And we said that the ways to multiply into 6, it's either 6 times 1 or 3 times 2. So there is no shortcut. So fortunately, to be able to determine which of the two sets of numbers you're going to use here, it's a matter of trial and error. However, there is a way to test your if the way of you playing with these numbers, if it gets you to the correct answer. So here's what you're going to do. Let's go ahead and try to use the 6 and the 1 here. So we'll put a 6 and a 1. So now the way to prove that it's the correct one, you're going to work with what one of my old teachers would say. You're going to do the smile test. My old algebra teacher, Miss Malik, would tell us that if your function is smiling, that means that you got the correct answer. So here we're going to multiply the 6 times the x. It gives us 6x. and then we're going to multiply the x times that 1, times the 1 here, and it gives us 1x. When you add them or you combine them, it has to give you the middle term here. If it's not correct, then you have to try with a different set of numbers. So let's go ahead and do 6x plus 1x gives us 7x. So that number combination is not the correct one. So let's go ahead and play with the numbers then a different way now. Let me see, let me erase this here. So that means that 6 and 1 didn't work out. Let's try with 3 and 2. So let's put a 3 here and a 2 here. It doesn't really matter when it's two positives or two negatives where you would put each one, but it would make a difference when you get to terms that have a plus and a minus. Okay, so in this case, let's go ahead and do that smile test. We have 3 times x gives us 3x, and we have x times 2 gives us 2x. When you add them together, it gives you 5x, which is exactly the middle term here. So your answer is correct. So in the case when it comes to factoring at the trinomial of x to the second plus 5x plus 6, the answer would be x plus 3 multiplied by x plus 2. Okay, let's go ahead and look at the second example here. Again, we had already distributed or placed the signs. We said that if we look at the second sign, if it's a positive, that means that both sets of parentheses will have the exact same sign as the first one. So we have x here and an x as well. And again, we're going to do the same approach of finding the factors of 6, or the last digit here, or the c in this case, right? We're going to find the factors of that, and we have come to the conclusion that it's 6 and 1 and 3 and 2. So let's just, since we already have an answer in the previous example here, we just carry it over, and I'll just show you that it's going to be pretty much the same. Okay, so here we have negative 3x times negative 3 times x gives us negative 3x. If we multiply x times negative 2, it gives us negative 2x. If we combine them, it gives us a negative 5x, which is the term in the middle of our trinomial. And if you want to make it a happy face here, we'll make it a happy face here. Look, there you go. And if it'll make you even happier, we can put another happy face here. There you go. Just for you guys, okay? So our answer when it comes to simplifying or factoring the trinomial x squared minus 5x plus 6 would be x minus 3 times x minus 2. Okay, now let's look at, as we mentioned when I was showing you guys the stuff that I have in my notes, that if we have negative instead of a positive on the second sign, so as I mentioned before, if it has a negative on the second sign, that means that one of your parentheses will be a plus and one of your parentheses will have a minus. The first term in this case, because it only has exponent to the second power, is just you will split it equally as x and x. Now here, again, we're going to be using the either 6 times 1 or 3 times 2. Okay, now one thing to keep in mind is that the way that I would tell students is look at your number combinations. If you add or subtract them from each other, will they give you a positive 1 in the 6 and 1? No, right? There's a 5 number difference. So to save your time, don't even use this one. In the second factors, there is a 3 and a 2. There is a difference of 1. So we just have to plug in that 3 in the positive because our answer is positive here. So we'll put a 3 and we'll put a 2 here. Now let's do the smile test. And we have positive 3 times x gives us positive 3x. And then you multiply the x times the negative 2 and it gives us negative 2x. When you combine them, 3x positive minus 2x, it gives you 1x. So our answer in factoring x to the second plus x minus 6 would be x plus 3 times x minus 2. Okay. Now, the same thing would go with this other example. Here we have x plus x minus, and it's just a matter of where you would arrange either the 6 times 1 or the 2 times 3, right? And we're going to go with 2 times 3 because the difference between these two numbers is 1. So here we would have the 2 positive and the 3 negative, right? Because again, 2x is positive, and we distribute the x and the minus 3, it gives you minus 3. So it gives you minus 1 here. So notice how that placement of the plus or minus makes a big difference.